So, discuss few questions here. Question number 41. Question number 14. Page number 0. 80. The question is, the body is projected vertically upwards with a velocity of 19.6 meter per second and reaches a height of 19.8 meter on Earth. If it is projected vertically up to the same velocity on Moon, then maximum height reached by it is. So what you can understand from here is, the body projected vertically upwards. Let us consider, is there some reference level? From here, a body of mass here is projected vertically up. It's a velocity, initial velocity u. So u is equal to 19.6 meter per second. And it reaches a maximum height of, h. It reaches a maximum height of 19.8 meters. 19.8 meters on Earth. Maximum height on Earth, you can say. U is initial velocity. And after reaching maximum height, what happens? Its final velocity will become zero. That is the meaning of it. Now, if it is the case, if it is projected vertically up with the same velocity on Moon, this is on Earth. Now, if you consider the same object of same mass on Moon, if you project this Moon, Earth, and on Moon, same object of mass, same velocity if you project, the question is, the maximum height reached by it, is it same or not? If it is Earth, maximum height on Earth is this much, what should be that? Say, it will be different, maybe lesser or smaller or more. Whatever it is, how much is that? What is the maximum height reached by the same object on Moon is the question. If it is projected same velocity on Moon, what will be the maximum height reached on Moon is equal to, provided velocity of projection on Moon is same as that on Earth. That on Earth, that is nothing but u. Let us say velocity of projection on Earth is u. Now, what you have to just remember is the maximum height formula in case of vertically projected body under gravity. So we know that the maximum height reached by a body on Earth is equal to what? H is equal to u squared by 2g, as g is here, and we are dealing with the two planets, Earth and Moon. Obviously, the height reached, and it is mentioned that if it is projected with the same velocity on Earth and Moon, what will be the height? So u is same. So you can say h will depends only on g, inversely proportional. So as you know that g on Earth and g on Moon are different, heights will be different. How they will vary? That is what by height on Moon is equal to g on Moon by g on Earth. So they have not given any relation between g on Earth and Moon. But you have to remember, usually they may give as a given data, but you have to remember that g on Moon will be 1 by 6 times g on Earth. That you can take it as g on Earth. If you take here you have to take this data as g on Earth is g equal to g by 6. G by 6 you have to take that. So gm on Moon is g by 6. G on Earth is g on Moon is g by 6. Then what will be this? On substituting this, you can say height on Moon. Yes, this one. By using this, I have written this one. Yes, sir. So for g height on Moon is equal to he height on Earth into g on Earth by g on Moon. This by cross multiplying. Yes. So this gives you he height on Earth into G on Earth is G. G on Moon is G by 6. G by 6. G cancel, 6 comes numerator and then it becomes 19.8 into 6. How much it will give is 19.8 into 6? 19.8 into 6. Let's do 8 into 6 is equal to 118.8. So therefore, you can say height on moon is equal to 118.8 meters. So options given here are yes, 19.18, 3.3, 9.8, 118.8. So 118.8. That's it. You understand?
Height of Earth compared to Moon is 1/6. 1/6 of the height on Earth.
Height on moon is 6 times. 6 times more. That means what you can understand is on Earth, G value on Earth and moon, if you compare, G on moon will be very lesser. So G on Earth is more. That's why even you can say the atmospheric molecules also will go hold it near to the surface. On moon, G is very small, so you cannot hold it closer to the surface. They will go to the higher levels. That's why no atmosphere will be there on moon. That's why you cannot. It is not that easy to live on moon. That's more. 6 times G value 6 times lesser on moon. Lesser on moon, so the weight will be very small, and hence the particles holding force, gravitational force on moon will be small. So they, even the atmospheric particles will also fly off. They will not stay on surface. That's why atmosphere will not exist on surface of moon. That is the reason why you can just, if you remember, the concept which we are just discussing on gravity, gravitation. So according to the same concept here, if it is the holding force is more, just if you jump here on Earth, if you jump, you will come back to the surface because of G is more, gravitational force is more. Whereas if you are on moon, if you jump with the same force on moon, you go, if you jump is 6 times. If you jump here on 1 meter height, this is say some 50 centimeters height on Earth, the same with the same jump on moon, you can go yes 6 times, 300 meters you will go. So just you can simply play like that. That's why just even for the astronauts also feel like there will be less gravity. Is it right?
Thank you, sir.
Hear the volume. This one. Gravity.
Sir, the spark of WhatsApp is white product. Sir, get booking.
I finished this slide line. Finish this, then you can go. This guys, freely falling motion. Have you just clear about the freely falling motion? Freely falling motion. Come here. Bring your chairs. So, freely falling motion is treated as the motion of a body which is dropped from height. Sit, sit. Yeah. If you consider a body of mass m, if you consider a body of mass m from at height h, and if you release this with initial velocity u equal to 0, this if you drop the body or if you release it, the motion of the body is called freely falling motion. Means it is falling freely. Means you also consider there is no air resistance. There is no air resistance. No air resistance. Okay. In such case, nothing will. The only force acting on the body is nothing but this is no air resistance. Second point you have to remember is only force acting on it is gravitational force. Gravitational force will act downwards. It will be pulling down. Gravitational force it will be pulling towards the center of earth. So as you are considering this is a ground or surface, means this is a flat surface, you can say that means the force will be acting toward the center. Earth will be somewhere here. So the only force acting on it is gravitational force. Gravitational force. Gravitational force. So due to this force, this will be moving down as this force is acting. So even though if you drop, it will be when it is said to be moving under the influence of gravitational force. When there is a gravitational force can be expressed as a mass times acceleration due to gravity or gravitation due to earth. So if an acceleration is acting on it, that as a force, gravitational force is constant, acceleration also will be constant. Acceleration is constant means the velocity will be increasing gradually. If it starts with zero velocity, velocity will be increasing so that the change in velocity gives you acceleration. Change in velocity gives you acceleration. So as velocity is increasing gradually, just before touching the ground, its velocity, if you say this is maximum velocity it obtains. Okay. So what is this velocity if you want to know? After traveling this much vertical distance, you have to remember the sign conventions also here. Whenever a body is moving down, displacement will be negative minus h, velocity will be negative minus v. Anyway, initial velocity is zero. Initial velocity is zero, and acceleration due to gravity is minus g. Downward motion all are negative. So now, to find what is final velocity? Final velocity, which equation you have to use? The equation which involves UVAS. So that is nothing but if you observe the equations of motion. First equation is V is equal to U plus AT, and second equation is S is equal to UT plus half AT square, and third equation is V square is equal to U square plus 2AS. We can say third equation we can use to find the final velocity by using by relating UVSA. UVSA. So we can use this second equation, third equation. Got it? So by using this, how can you do? Let us see. By using this, how can you do this? You can say as from from b square is equal to u square plus 2as, as v on reaching the ground is v, nothing but here is minus v whole square will become v square only, is equal to u is 0 because it is a freely falling body or dropped body. U is 0, so it is 0 square at 0 plus 2 into a is minus g, downward motion, and s is minus h. S is minus h minus g into minus h into is the product. So it becomes minus minus becomes plus, so it becomes 2gh. So v square is equal to 2gh it becomes. So v square is equal to. So therefore v is equal to square root of 2gh, square root of 2gh. So this will be the final velocity obtained or gained by a freely falling body after traveling a distance or displacement of h, displacement of after this much displacement. Whereas if you want to know what is the velocity gained somewhere at midway between these 2 points, then h is h by 2. H is something like half of it, half of this distance. What is the velocity? Here it is 2gh. Here if it is h by 2, 2 cancel. This, actually if you say this is capital H, if you take uh, something displacement, you can take it as a, if this is displacement, it is equal to h by 2, or if the total height if it is given as 40 meter and after traveling a distance of 20 meter, what is the velocity gain, like this you may get. See, let us do some a question in this form. Let us do a question, just to some kind of example, right? So the question is, find the velocity gained, find the velocity gained by a body. And if you observe one more point here, the velocity gain depends only on the distance traveled but not on mass. Once if you drop 1 kg body, 10 kg body, after traveling a distance height of 10 meters, both will obtain same velocity. What is the meaning of it? Did you understand? That means one more thing is in the absence of air resistance. So it is not depending on mass. So you no need to worry about the mass of the body also here. We say if you so we can if you consider the question, find the velocity gained by a body, any body, uh, uh, velocity gained by a body uh, in in midway. In midway means exactly half distance. In midway, midway when it is dropped, when it is dropped from a height of some height of 40 meters, from a height of 40 meters. Okay, so what you can understand here is, just if you draw in small diagram and if you compare, this is the ground, and if you are dropping a body from a height h is equal to 40 meter. So here dropping means initial velocity is 0. We are asked to find what is the speed, the velocity gained, or speed gained or velocity gained. Midway is exactly at this point. So that means that displacement travel should be s is equal to h by 2. So s, you can say s should be equal to h by 2 is equal to 40 divided by 2 is equal to 20 meters. So we know that the velocity gained after traveling a distance h, after traveling passing through a height of h is square root of 2gh. Here h is nothing but displacement, so it is 20 meter. So you can write it as a square root of 2 into g is 10 into 20. Is it clear? So 2 into 2, 4 into 100, 400. So square root of v is equal to square root of 400. It is nice. You can write it, also write it as 4 into 10 square. Root 4 is 2 and root 100 is 10. So you'll get is 20. So v will become 20 meter per second. Midway between, what is that? Midway means from the ground half of the distance. Okay, whereas just after reaching the ground, if you are asked to find, that means when h is 40 meters, if h is 40, then it becomes 4 into 2. 8, 800. So 8 into 100. So 100 comes out as 10. So root 8 can be expressed as 4 into 2. So 2 root 2 into 10. Or 20 root 2 it becomes. More than. So you can also say after reaching a distance of 40 meters if you are asked, then this is like you can also say this is the first part. The second part, after after just before touching the ground, you can say just before touching the ground, just before touching the ground. The velocity is given as v is equal to square root of 2g h. You can take the maximum total height, or what is small h also no problem, symbol anything you can use. So it is equal to square root of 2 into g is 10. H height will be before touching the ground, it has traveled a distance of 40 meters. So into 40, right? It becomes square root of, you can also just write down this as 2 into 100 into 4, right, like this, so that it is easily you can take this as a turns out root 4, you can take it as, or you can take this out as a 10. 2 into 10 becomes 20 into root 2. Root 2 will be 1.414. So you can say the velocity gain will be 20 root 2 meter per second. So it is greater than 20, but not double. Well, just it is not because of the 20 meters more distance, it doesn't become 40 meters per second. This 20 root 2 means how can you write it is the 20 into root 2 is 1.4, 414, 1.4, right? It is 1.4 into this 20, if we multiply with this 10 here, becomes 14. 2 into 14 is 28, 28. So 28 meters per second only it will obtain. Okay, like this velocity will changes. That is in case of freely falling machine. So another point here you have to keep in mind is the time taken to travel this distance. Time taken to travel this distance. What is the time taken? What is the time taken by a freely falling body? Freely. What is the time taken by a freely falling body? Freely falling body to reach the ground, to reach the ground or to strike the ground or whatever it is, to reach the ground from height h, from height h. So that means this is ground. If you drop a body from height h, if you drop a body of mass m here, the initial velocity is 0. How much time it takes to try to reach the ground or to strike the ground? So to understand this, just you have to consider what are the given, what is given data. So what is given data here? It is moving down with initial velocity is 0, mu is 0, right? And displacement travel while striking the ground will be h, right? And is moving down, so acceleration a will be equal to, what? Minus g, minus g. So what is the relation between SUAT? You can use, or there are two methods you can use here. Just from the previous equation, if you can make use of the final velocity, so by knowing u, v and uvat, also you can try the time taken. So that is if you take a final velocity v is equal to root of 2gh, in that in terms of that also you can try. So let us use this only. First method, let us try to go ahead with this. Then let us see how to find. By making use of this, what are the relations here? SAUT, which relation it gives? S is equal to UT plus half AT square. Yes or no? S is equal to UT plus half AT square. Where it is freely falling, so U equal to 0, and S is minus H. So you can take it as minus H is equal to U is 0, this time becomes 0, plus half into A is minus G into T square. Right? So minus h is equal to minus half gt square. Minus h is equal to minus half gt square. So minus minus cancel. So what you are asking to find? Time. So time taken. T is equal to 2h by g. T square is equal to 2h by g. So T is equal to square root of 2h by g. Is it clear? This is the time taken to reach ground from height h. So it also depends on height, not on the mass. If you drop a 1 kg mass or 100 kg mass from same height, in options of air resistance, so both will take same time. This is very interesting, right? Both will take same time. But you can do this experiment. You can do this experiment, but provided there will be no air resistance. Okay, provided there will be no air resistance. There will be no air resistance. There is a very great experiment. One great experiment was carried out. You can see that in YouTube also. You can try. So they have constructed very big, I mean, like a 10 floor height of vacuum house, vacuum chamber, and by removing the entire air in that, they have dropped one feather, and just like a peacock feather, and a 10 kg rod, spherical object. The feather and the 10 kg object both will reach at the same time, irrespective of their masses, because the time taken does not depend on the mass. Does not depend on the mass. There will be no air resistance. Provided there should be no air resistance. So you can say that time t is independent of mass. Is independent independent of mass. Actually, the concept based questions will come based on this only. So you shouldn't confuse. If 1 kg object is dropped and 100 kg object is dropped from same height, you may think a light object may heavier object may reach fast or something like that, because the force will be more, gravitational force may be more on that, this and that you may think. But time will not depend on the mass. It just depends on the height, provided if there is no air resistance. Okay? Air resistance will be there, means then yes, then actually it is not like heavy object. So air resistance in which direction is acting, upward or downward, it will slightly deviate. But provided if feather is there and a 5 kg object is there, if air is blowing up, feather will not come on top. It's because the upward force will be dominating, that will be holding the feather on upward only. It will be floating only. It may not come out. It may not come down. So, like that, the effect of air is air will place. The wind or air will place you. Okay? That is case of freely falling. Only these two concepts are important in case of freely falling motion. Whereas vertically upward projected motion. If you consider vertically upward projected motion. If a body is projected vertically upwards, then what kind of points you can remember? You can just try to find in case of vertically projected motion. Second case, in case of vertically, yes man, feeling hungry. In case of projected body. That is, if you have a body of mass m on ground, if you project this with some initial velocity, what happens? The only force here also should be gravity. No air resistance should be there again. No air resistance should be there. Then gravitational force will act downwards. As it is acting downwards, velocity decreases gradually, and final velocity becomes zero here. So let us say, after traveling, how much height it will stops. So that means what is the maximum height it can travel? So to find, in case of vertically upward, upward, upward projected body, what is the maximum height? Maximum maximum height reached can be given as, to find maximum height, you should know they are projecting with initial velocity but in upward direction. Upward direction means automatic positive plus u, and whatever upward or downward, acceleration will be always downward, negative. So a will be minus g. Are you following? So final velocity will become zero after traveling maximum height. Let us say that maximum height s is equal to h. It is upward is positive, so it is equal to what we are supposed to find. So you have to think about the relation which relates u v a s. So that is again, what is that? V square is equal to u square plus 2a s. So v is 0, u is u only, and plus 2 into a is minus g, s is plus h. So what will you get? You will get u minus or u square minus 2g. It's minus 2gh represent here we get 2 plus 2g h is equal to u square. So from this we can, what you can write the maximum height reached is h is equal to u square by 2g. Again here also it is independent of the mass in the absence of resistance. It depends on the velocity with which you are projecting. That's why even we have discussed in case of on the surface of moon and surface of earth. It depends on g. If you project with same velocity, it depends on g, not on the mass. Okay. So this kind of points just you have to keep in mind while dealing with this. Okay. Again, if you want to take the time taken to reach the maximum height, you can call as time of ascent, time of descent will be equal in case of up the options of air resistance. It is equal to u by g. And time of flight will be sum of this time of ascent and time of descent. And the equal in the options of air resistance, sum of this will give you 2u by g. So time of ascent will be equal to u by g, and this will be equal to time of descent. And hence time of flight will be sum of these two is equal to u by g is the time of flight. So try to just work out some numericals. So if you remember this, obviously you can do